Hello and welcome to the live stream for Behind the FDA Cybersecurity Guidance, where we will be taking you through a little bit of the history of what went into making the current guidance documents, what preceded them, what we were thinking as we sat in the office and were belting things out on whiteboards. So hopefully many of you will know us on the stream. Some of you will not. So we'll introduce ourselves and then kick it off. My name is Bo Woods. I'm founder and CEO of Cybersecurity. And I've been working in healthcare cybersecurity since 2004, roughly, with medical device makers, healthcare providers, physicians, clinicians, patients, cybersecurity researchers, and others. Including a stint at the FDA where I spent 1 year as an entrepreneur in residence with this guy, Seth Carmody. Seth, over to you.
What's up? I thought we were doing like a video game stream, so I'm a little disappointed that it's regulatory focused. No, it's all right. I'll take care of it. Seth Carmody, VP of Sales, which is a very strange title to hold. But I guess careers are weird. No weirder career than mine for sure. We can dive into it if you like. So running sales at MedCrypt. MedCrypt's a product services company that I stumbled upon after I left FDA. Spent a decade at the FDA. Policy wonk. Is that sufficient, Bo? Do you think it sufficiently covers my expertise at the FDA? Oh, I was a very bad reviewer. Yes, there we go. Got it. Medical device reviewer mediocre. So here we are.
There you go. Out of how many reviewers at the FDA?
700. I was probably like
Wow.
699, like in terms of like rank.
699. Nice.
Yeah.
Nice. So as long as you got that like 1%. Either way, like if you're the best
There was
1%
somebody
or the
worse
bottom
than me.
1%. Oh, okay. Well, that's good. That's good to know.
Had to be. Yeah. Every time I walked into my boss's office, she was like, "Oh." I remember I was at a conference one time and I actually apologized to one of the regulatory affairs people at whatever company it was. I'm like, "You got me in my second 510K. That just I think straight away you deserve an apology." She laughed.
Well, and then you got you did so well at that, you got promoted up to doing other things, right?
Yeah, it's a weird transition. So I think in 2016, 2015, something like that, I moved over to policy shop audit review. I think I get bored after 4 years, so I spent 4 years as a reviewer, and then 4 years at policy. So it was like literally 4 years and 2 months. So I don't know what that significance is, 42. But apparently I can only spend 4 years and 2 months in any given role.
And what did you do before you were a reviewer, Seth?
Um, Actually, and like I remember Bo, we would go back to origin stories. Um, this was the people were like, always tell me more, like hit the tell me more button or whatever. It's like, yeah, I started off as a chemist, like a literally legit PhD chemist. I wrote a thesis. It wasn't very good. And everything. And like I stood in front of a group of folks who are also like PhD chemists, and they're like, this thesis isn't great, but it's good enough. So they uh they gave me the PhD title. Studied at UCSD, UC San Diego. I still have my San Diego phone number. I think
Okay.
it just looks cool. Like when people say 858, right? They're like, this guy is military or something. And then went to Indiana University, and that's where I finished up.
Got it. So chemist to reviewer to writing cybersecurity documentation policy
Yeah,
for the
weird.
FDA. It's quite a transition. Yeah, I my degree is in psychology, and so I also have just a weird wandering stumbling pathway to getting here, but you know what? Whatever works.
What do you
I
what do
think,
you think? What was the linkage, do you think, between your degree and like what was the stepping stone to the next thing?
yeah, for me, it was, I always knew I was going to be doing something computery because I've always kind of been a geek. But I just found the coursework uninteresting, and hanging out with, some of the hardcore nerds and geeks. I was like, I don't feel like I fit in, and so I found some place that I actually enjoyed studying the coursework, and where the people were kind of cool and relaxed and more fit my vibe. And so I ended up getting a degree in that so that I could have 4 years of just enjoying the thing that I was studying before I went out and had to make money in the real world. Jokes on me. Uh, Ended up in computers and doing lots of various different things with them, and breaking them from time to time, um, always for good reasons.
You spent a stint as a consultant, yes? So you've been there. You've done that.
Yeah, I so I spent a few years at a hospital, uh, helping to unhack medical devices and build our security infrastructure, and then went out and did 5 years as just a consultant on the road. Actually, a couple of years I was on the road for about 50 weeks out of the year, going to all kinds of various different organizations and seeing how they did things. And I learned a ton, and got great airline status and hotel status, which was nice. And then came into the back office and started working with the business teams on how to run a consulting company. And after a couple of years of that, decided I wanted to go do it for myself. And very quickly found out that it's a lot harder than working for somebody else, and in ways that aren't the fun, cool. You get to do technology things. It's always like, how do you set up a business and get an accountant and do that? So, needless to say, when I uh, kind of ran into Suzanne and one of her counterparts in 2014
Mm,
at an Atlantic Council event, and we were talking about healthcare cybersecurity and medical device cybersecurity, and the initial draft pre-market guidance had just been put out. Um, and so I think we spent about an hour or two talking, and then kept in touch, ended up uh, talking a lot more. And this was just at the time when, I don't know where you were in your
mm,
fractured career arc, in 2010 to 2013. But that was around the time when there was a lot more security research happening on medical devices. This is when
yeah.
Barnaby Jack was doing some of his research,
Yes.
when Jay Radcliffe was demonstrating things. And so the kind of vibe that I got from Suzanne and team at the time was like, there's a there, we just don't know what it is yet, and we need to figure it out because it's critical for our role in protecting public health and the public health system and
Yeah.
patients, and for safety and effectiveness. Like, the cybersecurity is a vehicle to safety and effectiveness. So how do we
Mm,
get to understand that better, get to understand the people who are doing it better? And so I remember holding a small conversation. It was a handful of cybersecurity researchers, and Suzanne, I think Bakul was there, and I
mm,
don't remember who else was in the room. Maybe Afton. Um, and we were. It was like a half day, and we were walking through like security research, this, that, and I think it was Bakul who just like seemed, I don't know, somebody in the room. It seemed like they just couldn't get their head wrapped around who security researchers are, and they heard security research and they thought hacker and they thought criminal.
mm,
And so we understood that we actually had to break it down and say, like, here's why security researchers do what they do. Here's why they'll go and get a device and set it on the countertop and pull it apart to find the bugs and put it back together, and not be able to sit around the table with their family for a month because they're too busy poking and investigating. Um and and that kind of unlocked something. And once they understood that security researchers were here to help, they just didn't have the vernacular of speaking with medical device makers or the FDA. Then all of a sudden it was about, how do we translate between each other's languages so that we can serve public health better together, and so that we can harness the best of technology to serve this purpose and this cause, rather than inadvertently opening the door for accidents and adversaries to have some negative impact on the thing that we want to try and achieve. Um, and so that was kind of my entree into uh, working with the FDA is kind of coming in as a total outsider to the regulated space, uh, but being good enough um, at having that kind of mission drive and vision for seeing that we could work together and just kind of collaborating and building something together with them.
And obviously it had an impact because at some point I remember there was a headline, Jeff Shuren says, hire a hacker, right? So it was a good, I don't know if he got the message quite right, but like it was a good one to grab attention for sure.
Yeah,
But we all understood what he was saying, right? Yeah, go hire somebody that has an adversarial mindset. And I think it was important at that point, especially in the early policy journey, because and as you were talking, like I'm starting to remember stuff, like I've forgotten so much over the years, which is funny, but I remember thinking like healthcare are builders. They're usually like constructivists, not to say the hackers are not, but like they think about how can I put features together and string them together to have some, intended, health impact. They're builders, right? And they don't think in terms of breaking something. They don't think of like how this thing can necessarily be used in a way that it's not intended. There was
yeah,
a quote from Dr. Eugene Wasserman. I'll call him the prof. He hates that. But he said, it's not what it's designed to do, it's what it can be made to do, which I thought was a really great way to change the thought process when we were working with manufacturers to that sort of, oh, okay, I got you. If I'm not preventing it from behaving this way, then it could be made to behave this way.
right. Yeah, yeah. I'll never forget. I'm pretty sure it was Christian Demeth who said, as we seek to treat existing pathologies, we should take great care not to inadvertently create new pathologies. In other words, like if we're importing um, computing technology into all of the stuff that we're using to save lives, that computing technology has pathologies all its own. It has failure modes all its own. It has hazard conditions that are unique to it. And if we're not really careful, we could inadvertently import those in ways that go untreated. And
Mm,
so I think finding those ways to speak across communities in ways that they can both understand is extremely hard to do. But once you can do it and get them aligned, um, it really helps unlock some fantastic things. Like some of the best conversations and kind of breakthroughs that I've had talking with medical device makers or regulators is when you can get them to kind of drop into that adversarial mindset and then use the knowledge that they already have to
mm,
figure out the implications of it, right? Like in ways that I certainly can't because I don't have that deep base in biomedical engineering, for instance. But if I get a biomedical engineer to say, what could I do if I were trying to cause harm with this? And what are the safeguards in place for that? Then all of a sudden they just run wild and they find all the doors that they need to go close to the adversaries or the accidents. And that can really open up and unlock something. And I think that's one of the reasons why you know, bringing it on topic, that's one of the reasons why something like threat modeling is so critical and why the FDA has been pretty insistent in declaring that you need to do threat modeling. I remember sitting in a Northern Virginia conference room for 2 days with you and a bunch of other people from the industry. Um, Working on a whole threat modeling workshop and having some threat modeling experts come in and just walk through the process and translate it. And that eventually became an MDIC document, which I know the FDA refers to a lot. It's like the threat modeling for medical devices guidebook or handbook.
yeah, playbook. Yeah, it's interesting how things work out. It's like I remember Suzanne Schwartz came into and remember my office? You remember like I had my
Your
fake
office, yes.
office? Yeah, like it was like the decoy office and it had my name on it and it gave the air that would be there at some point after I came back from a meeting, but I never went there. I went to the secret policy bunker with tons of whiteboards and materials to create policy. Yeah.
Hmm.
I remember one day, well, Suzanne knew I was there, right? Of course, your boss should know probably where you are.
Right.
And then she poked her head in and she's like, what do you think MDIC should work on? I was like, threat modeling? I can't remember the year, but it was like, it was really early. Like, I mean, this is early
Yeah.
on. It might have been 2017, maybe. Like we're talking, I think
Probably.
people just started to care about medical device cybersecurity, medical device manufacturers as enforcement's gone up in 2025-ish. So that's like T0 in my mind. So we're talking like ancient history. So
Yeah.
2017-ish, that conversation happened, and that's why that whole workshop and MDIC effort and playbook came out.
Yeah, and I remember because the MDIC workshop was like 2020 or 2021 or 2022.
I think it was
It's
right
been
at
a
the yeah.
while. Yeah.
So wow.
Yeah.
Um,
Um,
it yeah, and then the origin story. Like I was thinking back to this. Like I remember, like you mentioned, you met Suzanne and Co around 2014, and the draft pre-market had come out. Like I remember my role in that policy document was I showed up to the meeting. I tried to figure out how the hell I made it into that meeting. Like why was there that I'm a chemist and I'm interested in software. Some terrible decision has been made. Like how am I here? And just remember listening to the conversation. I'm like, this is just really interesting. Brian Fitzgerald, I think if folks remember, Brian was the sort of
mhm.
had a lot of thoughts on cybersecurity, like the proto thoughts on policy, and he was the one that was really driving a lot of the aspects there, melding that with some of the sort of researcher community and things that we were getting from the researching community that sort of ultimately resulted in that first document. But I can't say that I wrote a lick of it. I was just there and hanging out and just vibing. So that was
Yeah,
a long time ago as well.
it was. But then you did end up picking up the pen for that, right? How did that happen?
I don't remember what I think Nick Thacker. I don't know if folks remember
Yeah,
Nick
yeah.
Thacker. He spent a time in Suzanne's group. By the way, Suzanne's group is an emergency preparedness and response group. They responded to things like Ebola, and I think I mean like which would have seemed odd maybe in the beginning, but I think it was a really you know astute observation that cybersecurity was very much like that at the moment, especially in that reactive phase. Um, but I don't honestly don't remember. I think Nick Thacker had probably taken all the comments from the draft and helped finalize that 2014 pre-market document. But I did steal the pen away from John Murray for the post-market guidance. He went on vacation like for 2 months because he's just like I'm going on a cruise in Europe and I'll see you in 2 months. And Suzanne was looking at the whole cybersecurity working group and she's like, well, this can't stop development for 2 months. I was like, yeah, sure, whatever, I'll do it. So John's a great guy, and
Yeah.
obviously I didn't steal it from him. I just like again, and he got back and he's like, yeah, that makes sense. Let's just do that. So
Yeah. Yeah. I liked working with John. He had some really good stories about like what came before, and how things happened. And I remember in like 2004, 2005, something like that. Um, I was working on a medical device that had malicious software on it and trying to get the manufacturer to fix the software vulnerability. It ran on Windows, right? It was some like missing Windows patch that allowed malicious software to get in, and then it just caused a reboot cycle on the device. So it was effectively unusable. Um, and I remember running across a document that I found out later John Murray had written, which was the original like off the shelf software guidance that said something like, if you have software, uh, not only are you allowed to update, we expect you to update it and to allow common protections that the hospitals need to put into it, like malicious software protection. And like when I pointed this out to the medical device makers, they're like blown away that this existed, right? We've come a long way since then. But I remember that was the first exposure that I really had to the idea that regulated medical devices, somebody had actually thought about software. And that's 20 plus years ago now. So it's, like you said, like a lot of people started paying attention around 2024, 2025, but it's been a long, long journey to even get there. And I think, one of the reasons why we just dove into this conversation, which is great, but one of the reasons why we wanted to have it is because so many people are not aware, they're forgetting about some of the history and the legacy and the things that have gone into getting to the point where we are today, where we can have discussions about threat modeling in medical devices, where we can have discussions about, what is an appropriate amount of safeguards on the authentication mechanisms for implantable devices when you want to connect and try and uh, update their programming and things like that. Um, so I think it's a testament to the work that the FDA and many medical device makers as well. A lot of really great people early on were trying to promote this idea that cybersecurity is patient safety within medical device makers, and I think a lot of it's kind of come together and stuck. And there is um, a wandering path to how we got here, kind of like you and I did in our careers. But a lot of those steps are important. And I think if you don't know what went into the documentation and the requirements and the guidance, it's hard to know how to really meet it. Um, and while the FDA has done a good job of going out on the speaking circuit whenever they release a new document and talking about it and what went into it, a lot of the decisions and some of those records and some of the rationale isn't transparent and readily available to everybody who is making a medical device, right?
We lived every word, Bo. We lived every word, and every word has a story, right? It, and we begged, borrowed, and stole content wherever we could. Consulted with experts, but really, my job as a policy wonk was really a synthesizer, which is weird because that's what I did in graduate school. As a synthetic chemist, I would build molecules, so I just turned that attention and focus to policy because I just didn't have the technology. Like I didn't have I didn't have the background in security, so I had to go out and sort of get people's opinions who had that background and then stitch it together into a cohesive framework. And it's interesting you mentioned it's wandering and sort of arrived at it. I love the call back to security and safety because I remember for a while, and I even made a slide like this probably in 2014 where I had the MasterCard logo, Venn diagram. Safety and security is two separate things and they overlap, and in the middle sometimes they're things that overlap and in the middle.
Mm,
And then I remember this epiphany. I was looking at it's sort of late in my policy days at FDA, and I was with Suzanne. I can't remember exactly. I think we were writing the proto 524B legislation, and we look at each other and we're kind of like recalling all of our learnings, and we look at each other and we're like, wait, no, security is safety, right? We just and I think we kind of had that hypothesis, but it took us 2011 to 2019 to sort of have the proof and data to be confident and write it down and back it up and be able to argue for it, which was it was a profound moment and one that I think shaped once we knew that to be true, even though I had sort of left the FDA shortly after that. That truth was true inside FDA, and they took that and ran with it. So really important data point to have supported with evidence.
yeah, yeah. I'm watching the chat over here. Somebody just dropped in. They can remember the mantra that got repeated, which is, look, we're an FDA regulated medical device. We can't patch or modify it without FDA approval. Um, and it's because that the mentality for a long time was safety and effectiveness are antithetical to cybersecurity without understanding, you know, cybersecurity people didn't understand the safety world. Safety people didn't understand the cybersecurity world, except for a handful of people back then. And I think the interesting thing when I ask myself why is that the case is like most of my career in cybersecurity I spent doing um, protecting confidentiality of data against threats.
Mm.
So most of the tool books are built around that. almost everything, if you go out and, you get the ISO framework for whatever, or the NIST framework for doing this, they almost all prioritize confidentiality of information above everything else. Availability is IT's concern, but it's confidentiality of data. But in safety critical systems, the bit that has to flip is you're looking at protecting the integrity and availability, to close that CIA triad in cybersecurity, integrity and availability of human life and public safety. And that is a different playbook. That's a different set of tools. That's a different set of consequences. Because if you look at the way that most medical device makers see security being done, it's something like, well, you got your password wrong 3 times, therefore we're going to lock you out for an hour. And if you're in an emergency department,
Yeah.
that's catastrophic, right? Like that just can't happen. That has real world consequences that are not about privacy. They're not about intellectual property or credit card numbers or anything like that. It's actually people coming to harm. It's people who have degraded lifespans or degraded quality of life because you have delayed care and treatment in, certainly some of the most urgent cases, like, heart attacks, strokes, and other things where that timeline really matters. So I think that uh, looking back, I think medical device makers weren't wrong. The way that they had seen security been done in the past and been told to them in the past was at odds with safety and effectiveness. It just took some concerted effort from people who believed that they were not at odds with each other to work out some better ways to do it and to learn from other areas too, right? Like medical devices are one example of safety critical equipment, but you have airplanes, which have been doing this for a long time. You've got cars, you've got some of the other things where they became connected on different timelines and different time scales. And so drawing from those, building something that's fit for purpose for medical devices, and then going out and continually refining and improving it. I think that's what the FDA has done an amazing job of doing over the last 20 plus years.
It's interesting. Like, is listening to you talk, I was remembering these slides that I think I baked shortly after I left, and it helped kind of solidify, the axioms that we sort of uncovered during my time there. One of them was, and I'm trying to thread the needle here. I haven't thought about this in a long time, so I'm gonna try to. I'll try to do it in a minute and 15 seconds. So time me. Um, the whole bar to market, right, was it's reasonably safe and effective. It's not 100% safety. It's not 100% efficacy, right? So there's inherently risk inside this contrivance, right? Which is, I think, a word they use in the law, which is a fantastic word. Uh, uh, I don't think I ever got to use it in my policy days. Um, and what I was thinking was, well, you provide an evidentiary basis that establishes a static sort of risk profile, right? Like we can say that we have reasonably safe and efficacious because we have done our due diligence and we have characterized this surface, this risk surface. And what security ultimately brought was it brought an uncertainty. It brought an uncertainty to that dynamic uh, relationship between benefit and risk, and tipped the balance towards risk unless we could demonstratively prove or show that we could maintain safety and efficacy um, while under duress. And a graphic would be amazing right here. So I'm not going to go that far and draw it. But it absolutely, for me, is that quintessential point about security's relationship to safety and efficacy, and how it really upended the model the FDA is operating under, but shows how flexible and creative they were in adjusting to that equation.
Yeah, I think that's a great point. And one of the things that I like about reading through even some of the early software documents, like I've traced this back to 1999, some of the documentation from there, and they've continually made a point that likelihood should not be an indicator of whether or not you do something for software. And one of the ways that they phrased it, and I don't remember what document this is, but it was something like, we assert that if an error has occurred, it will recur, and
Mm,
therefore you should treat it as if it will be a recurring thing and address it. And I think that that's really, really interesting as a concept, because we don't typically in software, we don't typically talk about that as much. But when you have these types of interactions that can carry some risk of whatever failure mode manifesting that you're thinking about, um, and you repeat that interaction dozens, hundreds, thousands, millions of times a year, of course, even something that has a very, very tiny risk or likelihood of recurring just by accidents will happen a handful of times, right? And so kind of leaning into that, one of the ways I describe adversarial action is you take something that's very, very unlikely to happen and you make it reliably repeatable at your own discretion, right? Like whenever the adversary wants, they can trigger this really weird, rare condition that almost never would happen. And you might see one every billion
mhm.
interactions, and you make it one out of every three interactions. And it's like, okay, well, that changes the likelihood equation completely. But that's all at the discretion of the adversary. That's all at their determination, at their whim. And you can't really rely on the kindness of known bad actors when you're talking about public health and public safety.
Yeah. Um, right on. I wanted to. Are you the host? Who's the host here? Can I act as
I
the
think
host for a second?
go for it. You're the host. You're the host now,
uh,
dog.
I wanted to uh, interject a word into the conversation, and we're going to discuss. So it's like remember Linda Richmond from SNL? I'll give you a
Uh,
topic.
okay, yeah. Discuss.
Rhode Island is neither a road nor an island. Discuss.
Coffee talk.
Cybersecurity. Cybersecurity Bill of Materials. Do you remember that policy gem?
I do. I do. That was a fun one.
I remember having this interesting conversation with Michelle Jump, I think now the CEO at MedSec, and she's like, "Well, Seth, what's a list of software? What's a software bill of materials?" And like, it's a list of software. She's like, "So a cybersecurity bill of materials is a list of cybersecurity?" I was like, "That's a fair point. Let me think about that for a second." Which there's a whole. We could probably do a podcast slash this streaming thing for software bill of materials unto itself. But what I'll say
Yeah.
is the idea is sound. So when you're thinking about policy, you're like, okay, well, um, does hardware count, right? You just sit back and you're like, remember Brian Fitzgerald would sit back like this and he'd be like, hmm. So you get very Brian Fitzgerald about it, and you're like, yeah, does hardware count? And you're like, well, by the way, this was Meltdown Inspector was occurring at the time,
Hmm.
so I blame that. It's like, well, yeah, I guess the chip matters. The I think ultimately it was the software firmware that was flowing through the chip, speculative execution stuff that ultimately made that possible. But it's like I guess the hardware matters. Okay, cool. Does the M6 screw matter? Okay, I guess that doesn't matter. So like, what hardware has cybersecurity in it? What? So yeah, you can
But if
see
you
the.
can take the M6 screw out and get access to the Ethernet port,
Are you a
yeah, it's a
policy
great
wonk too?
question. I have been called such. Yeah.
Yeah.
And I
Um,
think that Spectre and Meltdown is a really interesting example because you have a case where, you know, yesterday the threat was only theoretical. Oh, you're going to exploit some speculative execution in the hardware. Well, yeah, I guess maybe that's possible, but you'd have to do this and that and the other thing. You'd have to jump through so many hoops.
mm,
And then Spectre and Meltdown was announced. And like within a week or two, you could literally get a JavaScript framework that would run in your browser that would exploit this. So like within the time span of less than a month, it went from like theoretically, hypothetically possible, but probably would never happen to like, yeah, that happens all the time. And so this is where I feel like um, the type of risk equations that you tend to rely on in most of public health policy making um, break down. They have assumptions in them that break down because you can literally go from no knowledge or trust that it will never happen to trust that it is certain to happen within such a short time span that you can't adapt. And I think that this is why,
Mm,
we have such a hard time scoring risk because there's such a temporal distinction to it. The risk that you have today is negligible. The risk that you might have tomorrow might be catastrophic. Like, how do you even calculate that in a way that makes sense without some kind of like a continual process, without, re-ranking and rescoring things on a daily basis? And that's an almost impossibility, even if you've got a bunch of tools and tool sets, and it's like, all right, great, we're going to use all of those things, and software is going to do it, or LLMs are going to do it, and that's great, but it's still such a static thing that it will not keep pace with uh, adversarial changes or with new techniques or with the technology and the rate of change that happens there, new hardware, new software. So it's such a hard problem, which is what makes it fun in a lot of ways, is like thinking through and anticipating those types of things. But it makes it really, really daunting to do any kind of public policy around it when the lifespan is going to be more than a year or two. I think it's why, by and large, the standards world isn't able to do the things in cybersecurity that it is for
mm,
biocompatibility or electromagnetic interference testing or those types of things. And so I think it is certainly a mindset shift, and it is something that I think the FDA has done a fantastic job. If you look not just across the healthcare world, but at all other regulated industries around the world, I think the FDA has done an exemplary job of being able to get ahead of those types of things, to build the ramp in a sane and sustainable manner of compliance and getting up to speed, of allowing it to be flexible enough to adapt as needed, but also muscular enough to kind of force the industry to adapt these things, so that they can stay ahead of anticipated threats and reduce the risk aperture to a reasonable amount, in line with, like you said, the reasonably safe and effective uh, kind of concept.
mm. That's an interesting point. I do think that if I were to go back and sort of wave a magic wand over all the policies that I worked on, uh, I do think I would build in this notion of a maturity model, right? Like crawl, walk, run. I know you guys talk about that a lot. Just to emphasize like where stuff's hard, right? Like we deal with SBOM a lot and sort of in the day to day. And what a beautiful piece of policy. Hey, know what software you're using. Okay. Uh, know what the vulnerabilities against that software. Okay, we're like batting 100 here, like 1,000. We're really good. And then tell me what the what the risk is. Fantastic. And then what are you going to do about it? Wow, that is just, I mean, I do say so myself, but a very stunning piece of policy work. Really, just
Yeah,
round of applause. I mean, come on now. In practice, it is the hardest thing I've ever seen. Like, it's crazy hard for reasons that
yeah,
you were just outlining. It's like we're not even there yet. Like, we're not even
yeah,
able to do it to that in the spirit, even when people want to. It's
yeah,
really interesting.
yeah. We could. So the S-bomb history podcast will be a whole different thing. And that one literally will go on for a week at a time, depending on who we talk with it
Bo, did we
about it
settle
with.
on a format yet? What did we settle on? Did we remember early days?
Yeah, the
Is it
format is
gonna be
chaos. Whenever
SWIDS?
we feel
Did
like
we?
doing one.
Is it SWIDS? I don't know. Who knows? Let's figure it out.
Um, yeah, no, I mean, like, the thing about S-bomb is, in theory, it's easy. In practice, it's a little bit harder. Um, in practice with legacy systems, it's almost impossible. There's like a range of possibility. Like I remember, you and I were working on the software as a medical device pre-certification program, which I think was a brilliant and fantastic idea. How do you create public policy in a sprint agile mindset, taking advantage of the capabilities that exist when you are software alone and when you're probably always internet connected, right? It's like, great, we can see those as weaknesses or strengths, but let's lean into the strengths and see what we can build. Um, and I remember talking with some manufacturers, and they would say things like, "Oh, you can't know what's in your software. Like you can't generate a software bill of materials. It's impossible to do." And like no one in the history of mankind has ever been able to do that. That's You can't do it. It's an impossibility, right? And then like talking to, on the other hand, some other manufacturers, they're like, how can you build software without knowing what goes into it? Wait, explain this concept to me. Why do people think that that is not a thing? Like we we just accidentally, as off gassing, generate software bill of materials all the time for quality reasons, for reliability and normal software mechanisms. Like how do you have repeatable builds if you can't know it? And so like this diametric opposition, but I think they're both right in some old ways of thinking about it. Like you made the software once and then you send it out, and that's like a very 1970s 1980s way of doing things. And then it's like, well, you make the software and you make updates for it and you're going to do these things, so you need to keep around the engineers that knew how to do that, because their development machine was the only one that had the development environment that could actually reproduce this. And then you get it out the door, and like, don't tinker with those machines because they might just break. And everything that they know was written down in a static text document that we PDF'd up so we'd have it just in case they won the lottery and weren't going to work here anymore. And then of course through 7 different acquisitions in 20 years they retire and go somewhere else, and like all you've got is the PDF. So like of course you can't generate the software bill of materials for those old things, but for anything new, like again, you just like, this is the way that it happens. I threw my code on GitHub and GitHub automatically built a dependency graph that, gets me 60 to 80% of the way there. It's like, it just becomes easier with time and with better technologies, better capabilities, and learning those lessons. And so I think that SBOM is a great example of where the FDA saw the capability existed. It just wasn't always practiced, and said it's such a game changer in terms of being able to identify systemic vulnerabilities that affect the entire supply chain or the entire ecosystem for a certain product. It's such a game changer in our ability to understand complexity and dependencies and potential interactions at scale, that we want to know what's in there. And by kind of forcing the industry to take that policy step, then you start generating the practices and the tools that make it just easy in what you
Right.
do, right?
Yeah, I think that's a great point. It's like, is it physically impossible to do? The answer is no. And two, is it worth doing? Yes. Okay, so FDA's job is to get people moving in that direction. And I remember, I mean, there's plenty of examples. For the reason for reasons too that are coming to mind is that Rios, who I think you gotta mention Rios because he was there, like he
Yeah.
was there.
Yeah.
He did some research on the Alaris pump,
Mhm.
and the headline was 1,400 vulnerabilities. I think 16. Somebody's got a fact check me on that. I think it was
Yeah.
1,416. Let's see if my memory serves me. This is what, 2013, 14, something like that.
Probably.
And he said, well, what's the update? Like, what's the fix? It's like 2 Java updates. Okay, cool. So we should know what's in it, and then one of the biggest hammers, like we can take care of a lot of this attack surface with 2 updates. It's like, okay, that seems like it should make it in a policy someplace, right?
Yeah.
And then
Yeah.
the last one was WannaCry, which is a very interesting time to be a public health regulator and policy wonk. And that really showed me how important it was to even take that further and say, how do we connect this information to the people that are consuming the technology, right? The delivery
Mm.
side. And I will say, like, that's still a frontier. Like from everything that I've been involved with, getting that information out and actionable in the delivery side is still in its infancy. Doesn't mean that we shouldn't be doing it, right? But we should still, keep in mind like where we are in that journey, even though it's been a while. I thought this would be done in
Yeah.
like 5 years, by the way. It's going on like 20 something. So I don't know how much time it's going to take
Yeah.
to get over the finish line.
Do you mean the conversation around S-bomb or this podcast?
Both? I don't know. Yeah. No, just like I didn't know it at the time, but I think and it's been tremendously rewarding. I've been on a part of a piece of societal change, right? This has been a part. This is a societal change level thing, and I don't know about you, but I had never been a part of one, and I was like, well, this should be like take 2 years, right? And I remember looking at Kevin Fu, and he's like, what are you nuts? It's like 50 years, easy.
Yeah.
So we're Kevin Fu, if you're on the betting platforms, you might want to lay down a bet for societal change. I thought he's
Yeah.
probably more closer to the truth.
Yeah. Well, I think we've gotten in all of our name dropping by now. And somebody else did mention Kevin in the
Oh,
in
sweet.
the show notes and some of his early research in 2007 or
28.
8.
Yeah, 2008.
Yeah,
Yeah.
on implanted cardiac devices. But I think we are running over time. Our mysterious producer, who may or may not exist, is giving us the symbolic cut
Wrap
symbol.
it up.
So I think we got to wrap it up. So thank you, Seth, for being on. This has been amazing. Hopefully, folks who joined in liked it too. We didn't even talk about Mythos. We didn't even talk about a lot of the things we wanted to get to. So I don't know. Maybe we'll have to do another one of these.
All right, I'm game. Thanks for
All
having me.
right. Cool. Thank you, everybody, for
Everybody.
stopping by. And thank you, Seth. And we will see you again very